that we're looking at anyway. So it's the verification and validation. Has it started recording? Yes, okay. All right, so yeah, it's the verification and validation slides. So I can go ahead and, for the purposes of the recording, show that this is the set of slides that I had posted and intended for you guys to take a look at in preparation for this. The main thing is there's a lot of detailed information in these slides, but some of the main things that I think when I first learned this material that I really felt need to be set out is a lot of times we get these two terms confused. We kind of say we verify or we validate, and we kind of we interchange them, but they're actually a little bit different. They're both important, but if we look at verification as being kind of the question is, are we building the product right? So it's more about does the final product conform to the specifications, to conform to the requirements? So if we have, let's say, a requirements document or a set of requirements models or something like that, and is what our design and then our coding and our testing, is this all being done according to what the requirements say it should be? The other side of that, the validation, is more, are we building the right product? And so kind of, I guess for me, what I would say is they're similar, because ultimately what we are really trying to get to is we want to make sure that what we deliver to the customer or to our customers, to our users, is what they wanted in the first place. All right, that's what our long-term goal, that's what ultimately we're trying to do is, right? But along the way, if we look at theirs, making sure that we do things right along the way, we can get there. And so again, validation, are we building what they actually wanted in the first place? Well, if our requirements are done improperly, if our requirements do not correctly identify the needs of the customers, then we may be able to verify the product. We may be able to verify that we built things correctly according to the requirements, but we'll have a harder time validating that what we built was the right thing for what they wanted. So this is, and again, what a lot of what we're talking about here is how to do this in a systematic engineering type of way, right? Again, as I've said before, as you guys will hear me say many times, is as oftentimes the way that software has been developed has been more kind of what we call the ad hoc process of just kind of sitting down and saying, oh, this is what the customer wants, that's what I'm going to start doing. All right, I'm just going to type it out. And then we have a hard time testing it. If we test at all, the customer may be upset, because it isn't what they asked for, or sometimes what really can oftentimes negatively impact our ability to produce the right thing is if the customer doesn't really even express all of what they're thinking about. So for example, if we deliver something according to the requirements and the customer agreed with the requirements, but then when we deliver the product, they're like, well, I know I said this, but what I really wanted was, and they didn't really make that very clear in the beginning. It's not that, I wouldn't say that they were lying about it, but just that they weren't clear, then that can cause a big problem, right? Because if things are not clear in the beginning, then programmers will do things the way that we think that they should be done, which may not be exactly as the customer thought that they should be done. Okay. So let's see. What was a couple of other things? Again, this is the waterfall process type of thing we're talking about, and it's just the whole idea is that this whole verification and validation, we're doing it all along the way. It's not something that we wait till the very end to do it, it's not like testing is verification that what we ended up with in the implementation conform to the requirements, right? We don't, it's not that we do it that way, it's that we do verification and validation all along the way. So as we are moving along from one phase to another, we keep doing it over and over. So basically, so it's kind of this idea of what are some of the verification and validation, and we'll shorthand that, call it V and V. So what are some of the tasks and inputs and outputs that are in the conceptual phase, right? How do we do that as far as the concept? So that's at the very beginning. That's where the customer determines that they have a need, and they say, okay, how are we going to do this? Okay. So as you'll see throughout this, the conceptual phase, the requirements phase, the design phase, the implementation, testing, installation, and rollout, all of these are going to have their own set of tasks to make sure that we are performing this along the way. Again, what we would like to do, what all of this is kind of helping us do, is find problems early and correct them early so that they don't show up later. If we waited, for example, until it was time to, build and deploy a product, if we waited until then to make sure that what we made and what we have is what the customer asked for and what they require, if there are any problems that show up at this point, then we don't know where those problems showed up along the way. Was it some problem that was way back here and we didn't know about it and we didn't hammer it out then, and we didn't deal with it then? Is it some problem that was introduced in some of these middle phases, right? And so the idea is, if we do V and V tasks along the way, then we can have a better chance of getting to the end with fewer problems. All right. And again, just like with everything we've talked about so far, and everything as we develop the whole idea of software process and software engineering, is it's going to cost something. It's going to cost time, it's going to cost man hours, it's going to cost money to be able to have these tasks implemented along the way. The thing is hopefully what we're striving for is that the cost of adding this stuff along the way will be outweighed by the benefit long term. All right. So we will have a better benefit long term that these costs will be mitigated, basically. Okay. All right. So let's see. Trying to think what else I wanted. The concept of a formal review is a big part of verification and validation, that we will make sure that as we go along the way, as we hit these different milestones, the technical, formal review, the managerial, and again, we don't have, I think we talked about this once before, we don't have to have the entire team present for these meetings, but we do need to have people who are, basically we need to have a specific set of people that are like they're tasked with signing off, so that until we get their go ahead, we can't move forward. All right. Let's see. All right. So again, you have a team leader, you have team members, you have someone, the writer. This might be also someone that might take minutes as well, kind of keep an idea. Because if you allow for people who are in the meeting to be able to just talk about what they need to talk about without having to feel that they need to take notes on what other people are talking about, if there's somebody that's in charge of doing that, then that can be a big help as well. Let's see. Okay. Trying to see what else I wanted to specifically talk about. It was Right. So these are some different, so this comparisons of these things. So this whole previous set of slides here with the walkthrough, inspection, formal review, right? These are all different aspects of how to perform these verification, these V&V tasks, right? So, yeah. So basically this comparison of some of the aspects of them. So the objective, right? The objective of a formal review is established in some statement of objectives. An inspection is, the objective of this is we're trying to detect and identify any defects. So an inspection is where we kind of like get down into it to try to see, okay, are there problems? And remember that there was a difference between a defect and a fault, right? Right, there was a difference between the defect and the fault, that just because there are problems in code doesn't always mean that means it can't go out, right? We also have to identify those that are actually going to result in an error, where a user or a customer would actually see a problem. All right. So anyway, so this is some of the comparisons of how we would do these things. All right. Comparison of how those would work in a V&V format. Okay. All right. So anyway, so this is basically what we were talking, what I'd asked you guys to go ahead and take a look at today. I also wanted to go ahead and say that another aspect, another benefit to us having a shorter meeting today is I know that some of you are probably still working on your summary for those documents that's due today. So I wanted to go ahead and give you some extra time to be able to work on that, some to write that up. So I did see that some of you had already submitted that, and so thank you for those who did. So did you guys get a chance to look over these slides over this past week?
Actually, I checked them.
Okay. Was there some confusing parts? I mean, what was it that?
Well, there wasn't any problem. For example, like it again, it made sense. Like this is like the summary of this class to me. Whenever I read something, it's like, yeah, it's correct. Everything makes sense. Like since I had some experience in the field too, like I feel like these are like a must. They should be there.
Mm-hmm. Yeah, I agree. The interesting thing is, and maybe I come from I mean, I'm being a bit older. I come from a time when, you know, a lot of these things were new to me. When I took a similar course to this the first time I started looking into quality assurance. Over 10 years, it was over 10 years ago, like 12, 13 years ago, I think. But even then, it was like, yeah, I mean, we kind of do some of this, but it really wasn't common, right? And I think for what has hurt our field in a lot of ways has been that we have tried to apply traditional workforce style mindset to the development of software. You know, so traditional production, for example, manufacturing, traditional manufacturing ideas where if you get behind on a deadline, you just throw more people at it, throw more workers at the problem, and it gets done faster. All right, that was the way that people would build buildings faster if a building was behind schedule, or the way that if you were trying to build, you know, so many cars, right? than what you would do by a certain day. And if you found yourself that you didn't build enough cars, you would just add more people and say, here, build more cars, right? And that was the way things were done, for manufacturing purposes. And I think a lot of times we would take that same approach to software development and would actually, it was causing more problems. And I think so what we're doing now to study these things and learn, okay, are there better ways for us to be able to do the things that we need to do? And I think especially since, I mean, I don't know if there's a statistic. Maybe I should look it up to see if there's some actually an official statistic on the matter. But it seems to me that so much software development now is maintenance, is maintenance, expansions. There's not a lot of new system development, right? So, even like you look at like operating systems, Windows operating system, I mean, not a lot has changed in terms of the look and feel and for how it operates. Not as far as the core of how the user interface of an operating system works for a Windows operating system. It hasn't changed a whole lot since 3.1, right? You still use the mouse to double click on a file to open it, right? And now there's a lot that has changed, there's no doubt, but really, I mean, I think for the most part, I would imagine most software development, again, I don't have a hard statistic on this and I would have to look it up, but it seems to me it's more about expanding and maintaining what already exists rather than actually coming up with new software development. And so what I think, as far as what we're talking about here, what we've talked about for the past couple of weeks, has been about is part of the problem in maintenance is a lot of the time that's done, that is spent on fixing problems that could have been caught in the initial development, right? And so I think what we're introducing here, what we've talked about for the past few weeks, what we're talking about with the verification and validation is adding these steps along the way to make sure that then we don't have problems later that we have to deal with. Yeah. And remember, I said before, one of the hardest things for stuff like this to get them going is you're telling people, okay, we need to spend money. We need to spend money now, or some type of cost, time cost, financial cost, taking people away from other projects that they could be working on. And the idea is that what we're hoping for, what we are saying is going to happen, is in the long term, this is going to cost us less. Right. So, yeah. So that's kind of what we're doing here with this V&V stuff, is talking about how to add those tasks along the way. Like, we get to the requirements phase and we make sure that what we are, the requirements document that we are that we're creating is what the customer said that they wanted, or accurately represents it. Right? I actually just saw something reminded I wanted to tell you guys to say here with this. So I'm going to share the screen on this one. This is the slide I just pulled up. Because I mentioned requirements, so I went to the requirements phase here. Because I feel like one of the things that is counterintuitive, is one of those things that's harder for us to understand, is how even as early as the concept and even as early as the requirements phase, even back then, we have to be planning for the future. We have to be planning for what we're going to do much, much later. So if we look at, so if I back up a couple of slides and I see that testing is two phases in a waterfall approach. testing is 2 phases after requirements. And yet there's a couple of points here where in the requirements phase has to do with the task is a test plan generation, and a test plan is one of the outputs, right? So even back in the requirements, we are thinking about how to test what we're going to develop, right? And so that may seem counterintuitive because there may be like, well, how can you test? How can you write tests for code that doesn't exist, right? So that's why it's kind of a little bit counterintuitive, but I would say at the same time, it makes a lot of sense that that even back then you should be planning how you're going to verify that what you are creating is correct, what you are creating the right product. Sorry, the product right. You are creating the product right. Yeah. Have any of you ever, I may have asked this before, have any of you ever done test-driven development? Or do you know what that is?
I tried, but I couldn't, because I think it requires a lot of experience. I think it was my first job, and we were talking about this. We were talking about test-driven development, but we failed, and we failed very bad. We ended up doing everything and testing. We couldn't like test and do at the same time, and we couldn't imagine how things were gonna get bigger. I think it requires a lot of experience, in my opinion.
It can. I also think that I don't think it works for every system. So I'm going to take the silence from the others as to mean that maybe they don't know what test-driven development is, and that wouldn't surprise me because it's not very common. It's not very popular because for a lot of developers in the early, if you're initially starting test-driven development, it can be very slow, a slow process. But basically, the concept is that you write all your test cases first, and then you write. So, like let's say if you were writing in Java, you would write all your JUnit test cases first, which of course they would all fail because you have no system to test against. That you would say, okay, run this method in this class, and that class hasn't been created, so of course your test case is going to fail. All right, and then what you do is you write the code so that the test will pass. Now, the problem, for me, one of the problems is, if you don't write your tests well enough, then you can end up with code that's really not correct. But it can be very slow and problematic because especially if you have a lot of tests to run, then you can be kind of like writing code for each test case one by one. So I know it's popular among some companies, among some developers. I'm not a fan of it. I've used it before in a class that I took. I'm not a big fan. I don't particularly like it, but I also can see where it might have its place as well. But what I did like about the idea, at least, was at least to say, let's not think about testing after the code is written. Let's think about testing even before we start writing the code. Let's know that at some point, this stuff that I'm writing, we're going to test it. And we are going to verify that this is what it's supposed to be. So even back in the requirements phase, to start to even think along those lines. And I think that's one of these things that this whole V&V, doing things along the way, does, is it helps us understand that along the way, we're thinking about getting to the next phase. We're thinking about how we are going to do things in the next phase as well. It's what is it? It's a proactive approach instead of a reactive approach. So oftentimes, we've talked about this, about the ad hoc process, the ad hoc nature of a first year programming student. First year programming students are very reactive, right? You guys were all there at one point. You all were first year programming students at one point. You know that you guys are very reactive. You write the code, you run the code, it doesn't work, and you react to the errors. You react to the compiler errors or the runtime errors or whatever, and you try to fix that. And that's where there's an old joke, right, that, I have 9 bugs in my code. I fixed 1. Now I have 13 bugs in my code. Right, you guys heard that, something like that before, I'm sure, right? Or experienced something like that in your own code writing.
Bu adam değil. Allah rızası için.
Yeah.
Alo.
And
Tahir. Alo.
hello? So I'm sure you guys have experienced that before, right? Where you have a specific, you run your code, you try to run your code, you get a compiler error or a runtime error, and you fix the error, and it somehow fixing one error results in more errors showing up, and the problem is that actually those other errors were there all along. It's just sometimes a compiler error can hide a bunch of others, right? So by making sure that along the way, that as we do our requirements, as we do our design, as we implement, that we are thinking about the next phase, that we are thinking about how do we verify that this is accurate? How do we validate that what we're building is the right product? Like, as we do that along the way, then we don't get to the end and have to be reactive and try to fix a bunch of problems. Right? So much more proactive approach. So for those of you who do have experience, so Alper, you talked about how you worked in a company. I'm guessing the rest of you have at least had internships and stuff. Would you say that companies that you've worked for have had more of a proactive or a reactive approach to problem solving? Not all of you guys at once now. I mean, did you guys understand what I was asking there? I'm not muted. Oh, sure. Okay. So basically what I'm saying is that as far as the V and V stuff, the slides that we talked about and some of this other stuff that we talked about in the past few weeks, it's one of the things is that in order to plan for the next phase, so like even back in the requirements phase, we make plans for how we're going to test what we implement. All right. And so what I'm saying is that that is a very proactive way of doing things. But I believe that for me, at least when I was a full-time developer back 20 years ago or 15 years ago, right, that a lot of the companies that I've worked for were much more reactive in their approach. And what I mean by that is we would say, this is what we need to build, programmers go and build it. And we wouldn't make a plan, we would just kind of go and start writing code. We would test it, there would be problems, we would respond, we would react to those problems and try to fix those problems. Whereas what we're talking about here with software process, software engineering as the broader field, and then within software engineering, software process, and now this class, software quality assurance, is we're trying to say, let's not be let's not be reactive. Let's not say, oh, problem exists, let's fix it. Let's plan for what problems may come up, and let's make a plan for how we're going to deal with them so that they don't become problems in the first place, which is the difference is that the fixing the problems when they happen is a reactive approach. We react to a problem that we found out about. Whereas what we're trying to introduce now with V&V tasks along the way, with planning out our phases along the way, is we are going to be proactive. So before we get to the problem, we're going to do what we can to make sure that the problem doesn't happen in the first place. So the question, so all that I did is to say, the question that I had asked is, for those of you who have either worked for a company full-time, because Alper has shared some during our times together over the past few weeks about some of his experiences with his company. And I'm assuming that the rest of you have at least had an internship or two that you could speak about. And I'm wondering, the companies that you've worked for, would you say that they are reactive in how do they react to problems and try to fix them, or are they more proactive? They try to make sure that problems don't come in the first place. So what would you guys say? Right. I totally agree that you can't account for everything. But what I'm saying is so even like what we're talking about today, where the test plan generation, we're thinking about testing in the requirements. So we can't test any code in the requirements because we haven't written any code yet, but we can plan for how we're going to test the code once it's written, right? So for me, my very first job in software development was actually as a tester, and I've told you guys some of these stories before. But my job was to test. Well, a lot of times I didn't even know what to test until the developers sent me the code. So I didn't even know what to test until they told me, hey, this thing is ready, go test it. Well, what is it? Well, this is what it's supposed to do. So I had to then, after they had written the code, then I had to create my test plans, then I had to create my test cases, and then I had to test the code. Whereas in what we're talking about today is more, let's think about testing way back before code is even written. So what would often happen is if one of my test cases failed, I would submit a bug report, and then we'd have to figure out, okay, is there something wrong with my test case, or is there something wrong with the code? I'm not going to lie, it was usually the code, but that's part of what testing is all about, is it's trying to figure out where there are problems in our code. So had we had the test plan in advance, then the developers could have known, oh, these are the tests he's going to run. These are the types of things he's going to test, or he's going to need to test. And they could have been thinking about that while they were developing the code. And so that could have meant fewer test cases would have failed in that initial testing. Does that make sense? So, But you are right. You are. I will say you're right, Ivan. We cannot plan for every possible negative outcome. That's impossible. Yeah.
There's one little thing I want to add.
Sure.
I think it is very dangerous to try to be proactive while actually being reactive, because that is what we lived. That was the thing that I experienced. That is why I told you that we tried test-driven approaches, but we failed, and it was really bad, because being proactive is, of course, very good, but you should be sure that you really are proactive. Did you get me? Like, you think like, yes,
Yeah.
I know this is gonna happen. There will be a problem at that part, so we should prevent it by using abstract class here. Should use look at my UML diagram, things like that. And at the end, you fail. You may fail very bad, depending on your maturity level, of course. For a big company, that's not gonna happen. But if it's like a new company, or they are not very experienced programmers, I leave that. We thought we were proactive, but actually we were worse than reactive.
It can happen.
Honestly, I was thinking similar things. Being proactive, maybe for security precautions could be good, but for software testing, it may be very difficult.
Yeah.
But I guess when you said that we should test the code even before it exists, like abstract speaking, of course, but like how is that possible? It requires very good planning. It requires very good engineers, very good testers, right?
Yes. Now, when I say test, I guess maybe I was being a bit confusing. What I mean by that is, so we create a test plan. Now that doesn't mean that we actually write, JUnit test cases, but we have an idea of, okay, so let's say, for example, we know that one of the things that we're going to have to do is have a method that does something, right? Maybe this method takes some input and writes it into a file in a certain format. Okay, that's actually something that one of the companies I worked for, that was how we had systems communicate with each other, was through these network-based text files, which was so not good. But what we would format them in a certain way, so you'd have the first like 10 characters represented a person's first name, and the next 10 characters would be their last name, and so forth, and then some different other data fields like phone numbers, and it was a financial system, so there was a money field and stuff, and that was like a 12 character field or something. But so we would format the text on the line in the text file this way, and there was a method, there was a function where it would take this input and it would write it out to that file. Now we can say from the beginning, without even having any code written, that we know we're going to test this input and make sure that we get this output. Like, we can say this is what we're going to do. So, for example, I've told you guys the story before about how one system I worked on, there was a search criteria that was on financial, a number field, that if I typed in a special character like a $sign, it blew the system up and caused a big error. And the programmer was like, well, you can't do that. It's a number field. Well, I said, but it did, and this is what happened. And he thought, well, no user's going to ever do that. Okay. We talked with the manager. The manager confirmed my suspicion that yes, no users will actually do that. So we need to at least get out of there gracefully. We don't need to have them see this big Oracle error if they do that. Well, had he known when he was writing the code that that was the type of thing that would be one of my test cases, right? then he could have written the code in such a way to prepare for that situation, right? That had we planned it out in advance, because the way that it happened, we didn't plan. He wrote the code, I tested it, I get a failure, I send it back to him. He has to rewrite that code. He has to also make sure that all of his other stuff isn't, there's not problems with other stuff. Because remember, you fix one bug, you get more, right? So he has to make sure that all this time that he's now got to spend to fix this one error, had he known before he ever sat down to write a line of code that that was going to be one of the tests, then we could have known, then he could have been writing it the correct way all along. And it would have saved us a bunch of time, our company a bunch of time. So that's what I mean by testing in advance, like getting ready for the test in advance. And that's also what I'm talking about in terms of being proactive, that we were reactive and it cost us time. Whereas had we been proactive in that situation, we could have saved ourselves some time later. Yeah. Well, unfortunately, guys, like I said earlier, because of some problems related to this lockdown, I have to end this class a lot earlier than I normally would. So we'll end there today. Again, for those of you who haven't turned in your review, your literature review of those papers, the summaries of those papers, go ahead and get on that and do that tonight and submit that. And other than that, we'll meet again next week, same time, and we'll probably be a little bit longer next week since today was so short. Okay. If you have anything else you want to discuss about this, just contact either chat. Like I would say, go ahead and open up a conversation in this channel, and we can talk about things through typing. So we don't have to only meet and talk about this during the meeting time. Okay. All right, guys. Thanks for coming again. I'm sorry that I have to end this so early, but I'll see you next week. All right. Have a good weekend and
Thank you for
stay home, stay safe, stay healthy. Have they call, solid call. Let's hope this pandemic ends soon. All right. Have a good evening.
See you.
Thank you for the lecture. Goodbye.
Bye.